Data engineering is crucial in the modern data ecosystem, focusing on designing, developing, and managing data infrastructure and pipelines. It transforms raw data into actionable insights, ensuring data is clean, consistent, and available for analysis. This foundational role supports data-driven decision-making and strategic initiatives across organizations. Data engineers are pivotal in ensuring data availability, differing from analysts and scientists by building systems for data ingestion, cleaning, transformation, storage, and orchestration. They guarantee high-quality data is accessible for analysis and decision-making, forming the backbone of data-driven strategies. The data lifecycle begins with data generation or capture, followed by ingestion and collection into central storage. This data is then transformed to meet quality standards, ensuring it is ready for downstream use. Understanding this lifecycle is crucial for designing effective data architectures that support modern data needs. Data architectures are crucial in defining how data is stored, accessed, and moved. Modern architectures leverage data lakes, warehouses, and streaming platforms to handle vast data volumes and varieties. These systems ensure data is efficiently managed, supporting the diverse needs of today's data-driven environments. Data engineers require skills in programming, big data tools, and cloud platforms. They design, monitor, secure, and evolve data systems, playing a technical and strategic role. Mastery in languages like Python, tools like Apache Spark, and platforms like Amazon Web Services is essential. Their work ensures data systems are robust, scalable, and efficient. Reliability and efficiency are paramount in data engineering. Pipelines must manage vast data volumes and ensure timely outputs, crucial in sectors like finance and healthcare. This ensures data integrity and availability, preventing costly delays or errors. Mastering these aspects is essential for any data engineer aiming to build robust, efficient systems. The modern data stack revolutionizes data engineering with cloud-native tools, offering unmatched flexibility and scalability. Extract, load, transform processes are now preferred over extract, transform, load, as transformations occur within cloud warehouses like Snowflake and BigQuery. This shift enhances efficiency, allowing data engineers to focus on building robust, scalable systems that meet the demands of today's data-driven world. Data engineering is foundational for data-driven organizations, transforming raw data into clean, reliable information. Understanding these principles unlocks data's full potential, empowering strategic decision-making and personalized experiences. As the backbone of the modern data ecosystem, data engineering ensures that data is accessible, consistent, and ready for analysis, driving innovation and efficiency across industries.